This video looks at making measurements. And you might be thinking, well, heck, I can use a ruler, so let's skip this one. But there are a few things that we need to look at when making measurements and reporting the right amount of figures in our measurement. And these topics on reporting numerical data and measurements obviously don't make me want to flip cartwheels. We do get to some much more exciting things in chemistry, but you're going to be doing this all year long. So we have to make sure that we're making proper measurements. And then this is a skill that you won't even have to think about for the next 9 months. The amount of figures that you can report in a measurement is dependent on the measuring tool that you are using. So for example, here we have a measuring tool, a graduated cylinder. Graduated cylinders measure volume, and you might remember that you'll get this meniscus, they call it. If you look real closely at eye level, the water tends to kind of climb up the sides. And hey, guess what? After Christmas, you'll kind of learn why it does that. There's some very cool things that happen with water in a glass container such as this one. We always want to measure from the bottom, the lowest point of the meniscus. And so when I get ready to make a measurement, the first thing I do is check the markings on my measuring tool. Not all graduated cylinders are created equal. In the lab, you have different graduated cylinders available to you. In your drawers, there's a 10 milliliter, a little baby graduated cylinder, and a 100 milliliter. Their markings are not the same. So we need to kind of inspect this graduated cylinder and see what these little markings mean. So here, this must be the 80 and the 90. So this is 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. This graduated cylinder is marked off every 1 milliliter. Okay, important to know. What do those little lines mean? Every 1 milliliter. When you make a measurement, you start by recording all the numbers that you can just by looking at the markings on your measuring tool, your graduated cylinder, your ruler. Okay, so here's eye level. We'll kind of give her a little scary eye. Yeah! Alright, so we're going to measure at eye level. This is the 80, 81, 82. This would be the 83. And I get like it's really tiny in this picture. But are you maybe thinking that it's a hair below the 83? So we're probably thinking 82 point something. Okay, the best I can do with the lines on this graduated cylinder is 82. 82. So first you write down everything you know for sure, looking at the markings on the measuring tool. There is a line for 82. I know that this measurement hits the 82, and I'm pretty confident that it does not hit the 83. We're somewhere between 82 and 83, but the best I can do with these markings is 82. The markings are every milliliter. Okay, so now here's what makes this a more sophisticated measurement. In biophys or physical science, maybe that was good enough. Not in chemistry. You get to record all the markings on your graduated cylinder or your ruler plus 1 decimal spot as an estimate. Okay, so we're going to say 82 point something, which is probably what your gut was thinking. Well, if it's between 82 and 83, like I could take an estimate and I could at least tell you if it's closer to the 82 or the 83. I might think it's, I don't know, like a little closer to 83. So maybe I say, I don't know, 82.7. And this is a volume measurement, milliliters. Maybe I say something like that. A+. What if your lab partner says, oh, really? Because I thought it was like 82.6. I said 82.6 milliliters. A+. This last spot here, this is an estimate. I will not mark it wrong as long as it's reasonable. And again, this picture is kind of small, so it's hard to say that I would bet my life on it. But as long as you had 82 point something, you get full credit. Things that will not earn you full credit. What if somebody was like, I don't know, it's like 82. 82. Nope. Sad face. This would earn you 0 credit. Here's the deal. In any measurement, the last spot is the estimate. In any measurement, the last spot is the estimate. Well, no, I'm not estimating 82. I know that it hits the 82. I am confident that it is above 82. But if you just leave 82, you're saying, I don't know, it could be 81, it could be 82, 83, I don't know. Now, there are times when that measurement could be acceptable. What if you had a different graduated cylinder? Okay, so what if this was your graduated cylinder? This was 80. And then the next marking was 90. And then you had something that looked like this. The markings are only every 10. So now the best you can do on that little graduated cylinder is to say, well, yeah, I know it hits 80. I know it's above 80, but from there, I don't know. Only the 10s are marked off. So now, yeah, the 82, the 2 would be your estimate. And if somebody else was reading that graduated cylinder and they said, I don't know, 81 or 83, those would all be perfectly acceptable. The amount of figures you can report after your measurement is dependent on the measuring tool you're using. The ones that we have in the lab, the 100 milliliter graduated cylinders, are marked off like this big picture. They have every 1 milliliter marked off. So you'll measure the 82 and then you'll still get an estimate. Now sometimes you might think that it's right smack on the line, and then you can say, oh fine, I think it's 82.0. But somebody else might say, maybe that's like 82.1. You should always have an estimate. It'll be 1 spot beyond the markings of your graduated cylinder or your ruler. Another one that is not acceptable, if I were using this graduated cylinder, somebody could not say, oh, I don't know, maybe like 82.65. Nope. Sad face. These two are happy faces. This is a yes, and this one is a yes. Either of those two would be fine. No, this last one, again, sometimes people will say, oh, I don't know, I couldn't decide, 82.6, 82.7, so I'll just say 0.65. No, you can't do that. You just took 2 estimates. You only get 1 estimate. Now these are both estimates. You don't know that it hits the 6. There is no line for 82.6. So number 1, that's a guess. And then how can you say with any reasonable degree of certainty, oh yeah, that spot right in there, that's the 0.65. You don't know that. You get 1 estimate beyond the markings of your measuring tool. Alright, so let's try some. Let's see what we got here. Volume in milliliters with the correct amount of significant figures. Or in this case, they're just calling them figures. Significant figure is a term that's going to come up shortly. It really just means all the numbers that should be part of your measurement, including the estimate. So we look at our measuring tool, and we have to see what do these lines represent. So this is 20, 21, 2, 3, 4, 5, 26, 27, 28, 29, 30. Alright, this graduated cylinder is marked off every milliliter. So I'm pretty confident that I'm hitting the 35, the 36, And I'm pretty confident that it does not hit the 37. So I'll say 36, and then I get one spot as an estimate. It's probably a little bit over halfway, so again, maybe I say 0.7. Somebody else says 0.6, 0.8. That is totally fine. As long as you said 36 point something reasonable. So we have one decimal spot. We're estimating the tenths. All right, let's see the second one. Okay, my markings, here's 4 and 5. Whoa! Between the 4 and the 5, there's another 10 lines. So this is like 4, 4.1, 4.2, 4.3, 4.4, 4.5, and so on. This is like the little graduated cylinders in your drawer, actually, where not only do they have every milliliter marked, but they also have the tenths marked off. Exciting. Okay, so I'm pretty confident that this is above 5. 5 point. This would be 5.1, 2, 3, 4. What are you thinking? Like above the 4 but not yet the 5? So I'm pretty confident that I'm hitting the 5.4, and now I get another spot as an estimate. And so I might say, well, I mean, it's pretty close to the 0.5, maybe just a hair less. 0.8, 0.9, as long as it's something reasonable. So again, you can't just say every graduated cylinder gets one decimal spot or something like that. It totally depends on how it's marked. This one has a line for 4.5 milliliters. You still get an estimate. So now we get to estimate out to the hundredths place. But that's it, one estimate, beyond the markings of your cylinder. Let's see what I got in this last one. 20, 30, 20, this must be 21, 22, 23, 24, 25. What do you say, a little bit over 25? I know it hits the 25, and I still get one spot as an estimate. I mean, it's just maybe a hair higher, 0.2, something like that. If somebody else said 0.1, totally fine, as long as it's something reasonable. If they said like 25.9, I might question that. Excellent. There's making measurements. So again, I think sometimes in previous science classes you don't really think about that, but we do need to think about how we're recording our numbers and how detailed our measurements are. It's all dependent on the measuring tool you are using. Okay, so let's check these thermometers. At times we'll use alcohol thermometers, which will look kind of like this. Let's see here, this is 60, 70. So we must have 60, 61, 62, 63, 4, 5, 6, 7. Oh boy! What do you think? Like maybe a hair less than the 68? So maybe like 67.9? Something like that? 67.8? Somebody could put that. Degrees Celsius. These would both be smiley faces. Something reasonable. Now again, let's say you think it's right smack on the line. Here's again where sometimes people will run into trouble. They'll be like, well, I think it's right on the 68. And so then they just say 68. They get it marked wrong. And then sometimes they'll come up to me after a test or quiz and they'll be like, well, you marked this wrong on my paper, but the guy next to me got it right. I put 68, the guy next to me put 68.0. Well, we have the same thing. No, you didn't. Not the same. And that's where they'll try to argue. Yeah, you know, we have the same number. You just put 0.0. I just put 68, and they both mean the same thing. So I think I should get that point back. Because again, the last number is the estimate. This is totally fine. They knew it hit the 68 and they were estimating that's right smack on. Any of these would be totally acceptable, but not this one. Because that 8 now is your estimate. The last number in a measurement is your estimate. So you're telling me that you're not sure it hits the 68. A thermometer like this would only have a marking for 60 degrees, 70 degrees. But our thermometer has more than that. This thermometer has markings every 1 degree. Like there's a line for 68. So if you really think that it's right smack on the line, then you have to say 0.0. Those are not the same. The estimate is not the same. The second one, this will sometimes cause trouble. Okay, so we're below 0. Excellent. If you're below 0, you kind of have to read this backwards. So this is kind of like -1. This here would be -1, -2, -3. So I would read this as between -2 and -3. It's marked every 1 degree. It's a little bit higher than -3. So I'm going to say -2 point estimate. To kind of see what I mean by like you're reading this backwards a little bit, sometimes by accident people will read this as like, I don't know, -3.2 or something like that. Sad face. It's between -2 and -3. It's a little higher than -3. So maybe we're going to say like -2.8 or something like that. -2.8 is a higher temperature than -3.2. This is your happy face. So if you're reading a thermometer below 0, just be a little careful in those negative ranges. And the last ones that we have, how about some rulers? I record the length in centimeters. So again, check your markings. This ruler has a marking for 0, 10, 20, 30. So the best I can do is say, well, I know it's at least 10. But after that, it's an estimate. So it's somewhere between 10 and 20. It's probably a little closer to 10. I don't know, maybe I say like 13. Somebody else said 12. That's totally fine. This is your estimate. Where they'll get points off is if they say 12.5. No, that's a sad face. Because number one, you don't even know that it hits a 12. That's an estimate. And then how can you say, oh yeah, I'm pretty confident that's the 12.5. And again, if somebody said 12, that would be okay. But you only get one estimate. The second one, I know it's between 4 and 5. Maybe I say 4.4. One estimate, that's the best I get. And the last one. Oh Lord, let's say we got somewhere between 0.7 and 0.8. So I know 0.7. I think it's closer to the 0.8, so I still get one estimate. I don't know, maybe it's an 8 centimeters. The kid next to me put 0.79, 0.77. Those would all be perfectly acceptable. Now again, at this point, I think I would pause it and try the last two. They refer to a graduated cylinder. See what you get for the last two. Bring this back, and then check to see if you got the right answer. All right, so here we are. Let's check these over. How many decimal spots should be recorded in a measurement using the following graduated cylinder? Now Now again, there's nothing on this graduated cylinder. They're just asking me how many decimal spots I should record. So you got to check these markings. This is 48, 49, 50. And in between, this must be like 48.1, 48.2, 0.3, 0.4, 0.5. So let's pretend that I had something marked in here. Something right there. I could say 48.5. And I know there's a line on this graduated cylinder for 48.5. I still get an estimate. So if you think that it's right smack on the line, you would estimate 0. And then these are milliliters. We should be able to get 2. How many decimal spots? 2. It's got markings for the tenths, and then I get to estimate the hundredths. And again, that's different. This is not the same as somebody that says this. Because now they're saying that they don't really know that it hits the 48.5. No, I'm pretty confident there is a line on this graduated cylinder for 48.5 milliliters. And I'm actually going to estimate that it's right smack on the line. So this one's a sad face. Sad face. The second one, draw in a meniscus showing a volume of 18.2. So let's check these markings. This is 15, 20. So this must be 15, 16, 17, 18, 19, 20. So again, it's really tiny. But maybe something that's just a hair above the 18.2, somewhere in there. And again, this is a skill that you will use all year long. It's something that just needs to be embedded in your brain forever. That whenever you're making measurements in the lab, whether you're using a ruler, a graduated cylinder, there's all kinds of measuring tools that we use. I always write down the numbers that I know for sure off my measuring tool, plus one more decimal spot as an estimate.